Hello, question 4, the 2021 maths. Charlie is trying to cut a cake. The cake is a square with side length 2, corners at 0, 0, 2, 0, 2, 2, 0, 2. Charlie's first cut is a straight line segment from the point x, y to x, 0, where x is between 0 and 2, so it's in the cake, and so is y. Charlie plans to make a second straight cut from that same point to a point 0k, somewhere on the left hand edge of the cake. This will make a slice of cake bounded to the left of the first cut and below the second cut. Right, so that's just the picture essentially. So I don't think there's anything in the picture or in the text that isn't in the picture, so we can ignore the text and go off of that diagram. Part 1, find the area of the slice of cake in terms of x, y and k. Check your expression by verifying that if x is 1 and y is 1, choosing k is 1 gives a slice of cake with area 1. Well, you'd expect us to do that anyway. So what's this area going to be? We've got a parallelogram of width x and the average of the other side. So there's the half. We've got a y plus k. That is the area. So if we put in 1, 1 and 1, we expect to get 1. So we've got a half multiplied by 1 plus 1 gives 1. So I suppose we should put that in. A half times 1 plus 1 equals 1. Tick. Right, never asked for much there. Still operating at GCSE level, I think, for that one. Part 2, find another point x, y on the cake such that choosing k equals 1 gives a slice of cake with area 1. Right, so we have to have k is 1, so we need something which is summing over 2 times something plus 1 equals 1 on all of this, don't we? So we need to get some other point where if x was 2 and y was 0, then we've got 1 times 1 is 1. So we want to have the point to 0. I mean, they're going to be infinite numbers of coordinates that you can put into there, because that's just, well, yeah, you can just pick anything that fits really on that one. Right, so that's part 2. Part 3, show that it is only possible to choose a value of k which gives a slice of cake with an area 1 if both x times y is less than or equal to 2 and x times 2 plus y is greater than or equal to 2. Right, this all looks very similar to the equation. So if we've got area 1, area equals 1, then, because they don't have a in any of those equations, so let's stick that in and say we'd have x times y plus k would be equal to 2. So that's what we've got there, i.e. xy, I can see where this is going, plus kx equals 2. All of these things are positive. So we've got x, y, k all greater than equal to 0. Therefore, we have to have xy has got to be less than equal to 2. So if xy has gone above 2, we ain't bringing it back down again. And k has got a maximum of 2, hasn't it? So whatever value of k we've got, if we increase it up to 2, then it must be greater than 2. So if x, y plus kx equals 2, then, okay, well, and k is between 0 and 2, then x, y plus 2x must be greater than equal to 2, because we can only be increasing it. We can't be making it any smaller if we've got k at the maximum value. So, i.e., it must be larger or equal when k equals k max equals 2. Okay, part 3. I'm expecting it to get more difficult in a minute. What have we got here? Part 4. Sketch the region R of the cake for which both inequalities in part 3 hold, indicating any relevant points on the edges of the cake. Right, well, that's pretty easy as well, isn't it? I mean, okay. So we draw our cake. which is going from 0 to 2 on each bit, we have to draw x, y is less than or equal to 2. So that means we're going to be going through, well, okay, let's go through. So if y is equal to 2 over x when x is 2, y is going to be equal to 1. So we're going to have it going through 1 there. When y is equal to 2, x must be equal to 1. So that's going to be, well, let's put the coordinates. So 2, 1, 1, 2. And then now y equals 2 over x, line there. So we're going to want everything sort of left and below of that. But then we have to draw in the other line as well. So that is x times 2 plus y is greater than or equal to 2. So let's turn that into something more sensible then. So that is going to be y. We want to do the equals line. So y is equal to 2 over x minus 2 is what we've got there. So when y is equal to 0, we've got the x is equal to 1. And when, oh, we don't want x is equal to 0, so but we'll do y is equal to 2, then we'd have the x is equal to a half. So we're going to have another, well, it's a transformation on this. It's going to have the same sort of gradients going on, but we have to go through here at 1, 0, and we have to go through here at a half 2, and then draw another curve in there. And the bit we're going to want is between all of that. So all of this region here. Right, is that all of it then? Sketch the region R, yeah, for which both inequalities hold. Indicate any relevant points. So all the points on the edge are marked. Right, part 5. Let's get a new sheet up. Charlie may instead plan to make the second straight cut from XY to a point M2 on the top edge of the cake. Right, so we're now going up here somewhere for the second cut. In order to make a slice bounded to the left of the two cuts. Right, so we've now got all of that added in. Find two necessary and sufficient inequalities for x and y, which must both hold in order for this to give a slice of area 1. Sketch the region of the cake. Right, so we're just doing it all over again. Seems to be the case for this. So the area then in this, what is our area going to be? Well, let's make this a rectangle minus this triangle here. So it's going to be 2 times x for that whole rectangle. And then the triangle, so we want to do a half of the base, which is going to be, what was this point up here? M2. So x minus m times the height, which will be 2 minus y. So that is our area. Okay. And then what are we doing? We're then having to find two necessary, right, we have to turn these into the same sort of inequalities that we had before, if this is equal to 1. So let's expand a few things out then. And maybe I want to multiply by 2 while I'm at it, but let's do it in a few little bits. So we'd have minus 2x divided by 2, so minus x. Then we're going to have a plus xy over 2. Then we'll have a plus m, and then we'll have a minus my over 2. So we can do some factorising here. Well, that x cancels with that x. Multiply everything by 2 would seem like a good idea. So 2 equals 2x plus xy plus 2m minus my. So 2 is equal to x times 2 plus y plus m times 2 minus y. So that means we must have, if we're doing the same thing as we had before, we're going to be saying that x times 2 plus y has got to be less than equal to 2. So that's one thing. And then we've got, well, the whole thing, if we, m got a maximum of 2, isn't it? So we just up our m value. and say that x2 plus y plus 2 times 2 minus y must be greater than or equal to 2. So I've just done exactly the same as we did in part 3. Just done it all over again. Well, so we had more to do, didn't we? Sketch the region of the cake for both of these inequalities. Oh, good Lord. Right, okay, this is going to be a bit annoying then. Yeah, it really is going to be a bit annoying, isn't it? Well, okay, let's get our cake. The first one's going to be fine. The second one's just going to be a bit of a faff trying to work out where everything is. So 2, 2, and 0. So now on this, we're going to have 2 over x minus 2 is what we want to draw out. So actually, that's what we had before, wasn't it? 2 over x minus 2. Let's look at the previous sheet. And yeah, 2 over x minus 2. Right, so nothing's changed there. I've got this same thing going up from here. That was at a half, 2, and that was at 1, 0. Right, so that's dealt with that one. We've ended up with the same thing. And now we've got this horrible looking thing. So I'm going to have to expand this out. Now 2x plus xy. And then, because I need to make either x or y. Actually, do I need to expand this out? No, I don't need to expand that out at all. Right, let's not do it because I've only got one x in it. I just noticed that. Right, so let's do then that we can take this off of both sides. Minus 2 minus y. And then say x has to be greater than or equal to 2 I might regret this actually because I've got x the subject now, so I'm going to have to draw this sideways when I'm going to try and draw the graph, which might not be the greatest idea. I don't know. So, well, we'll see. X is greater than or equal to, we're going to have a 2 minus a 2, minus a 4, I mean, so it's a minus 2, so that would be 2y minus 2 over 2 plus y. Okay, so what is that going to end up looking like? When x is 0, we're having that y is 1. So it's going through here. It's going to have a negative, I think, on this, if it was the other way around. Just trying to think what the rotation would be. Well, let's try that. What's happening when y is 2 anyway? At the top. Y is 2. We've got x is a half. Interesting. So it goes through there. Oh yeah, that one was when x is 0. We've got 2y minus 2 is 0, y is 1. So 0, 1. Well, it must connect those up. And it's going to be, I'm just trying to think what direction it's going to be going in. If we were going to rearrange all of this, it is going to curve that way, isn't it? So yeah, I've got away with not making y the subject on all of this. And then our region is going to have to be all of this bit. Right, okay. So let's just double check. What if I did make that y the subject? If I had done that, I would have had 2x plus xy. Let's just make sure I haven't done anything daft here. Plus 4 minus 2y greater than or equal to 2. So that's just coming back to this point. I just want to make sure I've just messed all of this up. So let's make y the subject then. We can take the 4 off both sides and the 2x off of both sides. So we'd have y times x minus 2 is greater than or equal to minus 2 minus 2x. Divide by the x minus 2, which is negative, or 0, but if it's 0, it causes enough problems. So we're going to have to flip the inequality sign and then deal with all of the minus signs. So 2x plus 2 over 2 minus x. So we still got exactly the same values on here. When x is 0, we get y is 1. When x is a half, we're going to get 3 over 1.5, which is 2. Right, so we're in the same ballpark on all of this. And we've got a negative here for our 1 over x's. So, well, we could redo this as like split it into two fractions. So if we had a over 2 minus x plus b, then b would have to be minus 2 when we put that to look at the x coefficient. So b is minus 2, which means that minus 4 plus x plus a, I mean, is 2. So a would have to be 6. So we're doing y equals 6 over 2 minus x minus 2. So you can see we're going to have a negative. That gives us the shape of that gradient, and it gives us all of the points it's going through as well. But we didn't need to do that. Actually worked out fine just sticking with this, so I didn't make a mistake, which was my concern on that. Right, that was again, I would say that was a pretty easy question. They're not asking for a lot in this paper so far. I'd say all the questions so far, 2, 3, and 4, have been pretty easy. But it's probably a post-COVID effect. Although in 2021, I suppose we were sort of still in the midst of it, weren't we? So yeah, they probably toned the questions down a little bit for that reason. So that's question 4 done anyway.